Good morning and welcome to the National Museum of Computing. I'm Andrew Herbert, the Chairman of Trustees for the Museum. It's a great pleasure for me to be here today for this opening of the Raspberry Pi exhibit celebrating the 10th anniversary of the Raspberry Pi. I'm sure there are many enthusiasts in the room here who, like me, have various generations of Raspberry Pis and Picos at home. I've sort of slightly lost count, actually. And there's an even bigger pile of ones I managed to blow up, but there you go. So looking forward to the day, we start with interviews with Eben and talking about the way the company has grown. I thought I'd offer a personal perspective on it, which is almost a slightly embarrassing one. So back in about 2005 or 6, a group of academics that I worked with, I was with Microsoft Research at the time, were complaining about the students who were turning up to do computer science at university with a computer science A-level that was absolutely useless, and indeed certain universities, including the one in Cambridge, actually regarded it as negative A-level. If you had it, it was a reason for rejecting you as a candidate because you knew the wrong thing. And these academics wanted something done about it, and running a research lab, you feed off the research students those academics produce, and so it was a problem for us in industry too. So we had a meeting, and out of that meeting came a number of things, an initiative called Computing at Schools, which still goes on, which the British Computer Society took charge of. And we started building networks of teachers, and we started a campaign to change the curriculum. Also in that meeting was a Cambridge entrepreneur, a guy called Jack Lang. And Jack said, what we need is a new BBC micro. And to my slight embarrassment, I kind of said, well, we're not sure about that. What we need to do is fix the curriculum. But fortunately, as always, Jack didn't listen to me. And while I and others went off and fixed the curriculum side of things, he went down a path that led to the creation of Raspberry Pi. And it's been a fantastic success. So I look forward to hearing about how that story actually came about, despite my best efforts, and look forward to seeing the exhibit. I'd like to thank the Raspberry Pi Foundation for putting on the exhibition, for sponsoring it, and for a whole raft of other activities they're going to be doing in partnership with us throughout the rest of the year. So with no further ado, I'd like to hand over to PJ, who's going to run the rest of the morning, and we'll shuffle the microphones as we do so.
Thanks very much, Andrew. And I'd also like to take the opportunity to welcome you all here to the National Museum of Computing. Thank you all for coming. And also everyone watching on YouTube. Hi. Without any further ado, we've got two very special guests. Can I please welcome Eben Upton and Philip Colligan. Please make them feel welcome. Hello. Hello.
Hello.
So as I'm sure you know, Eben is CEO of Raspberry Pi Limited and Philip is CEO of the Raspberry Pi Foundation. So gentlemen, let's start right at the beginning. What is a Raspberry Pi?
Shall I do it? Because I say the words very frequently. So a Raspberry Pi is a credit card-sized computer that we developed in Cambridge in order to teach young people to program computers. And you can see some fraction of a Raspberry Pi here on the screen. I think probably enough, if you fit all the bits together, you probably get a full Raspberry Pi. And we've been making these things for about a decade, and they've gone through various iterations, but they all basically end up looking like a little green credit card. You plug into your television, plug a mouse and a keyboard into it, and you have a computer.
And we started to touch on the genesis of the project there. So where did you come into the story?
Well, I've been trying to build little. So I was a director of studies in computer science at St John's College. So I was directly exposed to some of these challenges with more the number, I think, than the quality of young people. The applicant numbers had declined very, very rapidly from the end of the 1990s down to about 2005. I think the nadir was about 2008, which was the year that we incorporated the foundation. So I'd been exposed to that. I'd been building little computer things for a little while before that. And these kind of two strands came together And this various people who'd been experiencing the decline from various angles, most of them in Cambridge, with the exception of this gentleman at the back here, Pete, who's up in the northwest. Various of us had been experiencing this problem from different angles, and really the Raspberry Pi Foundation that kind of came together in 2008 was the machine, the engine that was supposed to make this piece of hardware, this idea of a missing piece of hardware, the idea that as hardware had gone away, as programmable hardware had left children's lives, the number of people interested in computing had declined. Very much the idea that if we brought back a piece of hardware, perhaps some of that enthusiasm that we'd experienced in the 1980s might come back. And Raspberry Pi Foundation was the machine to try and build the machine.
Fantastic. And the name. Why is it called the Raspberry Pi?
That's John Crowcroft's fault. So John was a professor at the university in Cambridge, and the older of the two universities in Cambridge. As part of this discussion that Jack was coordinating at the computer laboratory, he sent an email that just said, "Call it Raspberry?" ? The idea of fruit-named computer companies, there are lots of them. There's Tangerine, obviously, yes. Apricot, Acorn, I think technically. There's a big one in California somewhere. So there aren't actually that many fruits left. There was a strand of. I remember that there'd been some discussion of MIT building an Apple II clone for this purpose. And so this is sort of this kind of slightly kind of patriotic, nationalistic thing. Well, if they can do it, we should do it. And Raspberry was slightly intended to be a. I think that was John's thinking. Anyway, so Raspberry is that, and then Pi is Python. Misspelt because we thought the Pi logo, the letter Pi would make a fantastic logo. And then we've ended up, obviously, as you can see, with a picture of a raspberry as our logo. But we didn't find that out until long after we'd frozen the name of the foundation.
So, over the years, Raspberry Pis have been used for all manner of things, from educational purposes to just because you can type of projects. Have there been any that really surprised you, anything that really stands out, an incredible use of your computer that you never saw coming?
You must have one.
Well, I mean, so lots of the foundation's focus, of course, is on young people, and so sort of they are constantly surprising us with what they do with Raspberry Pi computers. Let me pick a couple of examples. So, there's a wonderful, we run Coolest Projects every year, which is like a showcase where young people show off amazing things that they built. There was the mind-controlled robot, which was made by a young woman called Laura, which had a sensor that you put on your head, and you could train it over just a couple of minutes of sort of thinking a thought, like left, forward, back, right, and then the robot would respond. And Laura said to me, it worked much better for me because having no hair, the sensors got a good connection with my head. And then the other one that's very live at the moment is, we have Raspberry Pis on the International Space Station, so we have a program called AstroPi, and we've just sent new Raspberry Pis into space with a later generation, so more powerful, with a Google Coral accelerator and a whole load of new sensors. We're just reviewing the projects that young people have made using those sensors and the high-vis camera. And that is just mind-blowing, seeing the way that they're using machine learning programs, the sensors that we've put up there to explore issues like climate change, and just remarkable, really. So yeah, lots of examples of what young people do with them.
What's interesting about both those examples, and I think most of the cool examples, is they tend to be physical computing examples. My idea of what people would do with Raspberry Pi was very software oriented because I'm a software engineer and I thought people would write computer games on them because that's what I did with my BBC Micro and my Amiga when I was a kid. And this gentleman talked me into the chip we use, BCM2835 in Raspberry Pi 1, has a bunch of general purpose I/O pins, and Pete insisted on bringing those out to a header, and I was very much. My view was very much like, oh, really? People really going to do that? What if people short out the pins? Why don't we do that? But it's interesting that you're. One of the great things about general purpose computing, Raspberry Pi is a really staunch advocate of the foundation and the trading company are very staunch advocates of general purpose computing as opposed to appliance computing. wherever it is, it's in my pocket, my mobile phone, is an incredibly powerful computer, but it's an appliance computer. It really only does. Okay, you can write software for it, but people only really use it to do things which are within the kind of purview of what its designers imagined that people might do with it. The interesting thing about real general purpose computing, and particularly general purpose computing that has interfacing capabilities that let it talk to the outside world, is that the universe of things that people do with it is much larger and kind of extends a long way beyond what we had in mind, what any of us had in mind when we started the project.
Amazing. So one of the things that stands out to me is that your project has now become a part of the British computing history. So it's fantastic that we have the exhibit here, but how does that feel to go right back to Colossus, which is, I can actually see it from over here, through the Leo computer, and here we are now.
It's quite cool, isn't it?
It's pretty cool.
Pretty cool.
It's quite cool. And we sold 46 million Raspberry Pis. It's a lot of, it's kind of to be the, I remember when we launched the Raspberry Pi Zero, and there's the famous Tom Watson quote about there being a world market for maybe 5 computers, and somebody did they had the Leo computer being installed. I think it was a Leo computer being installed in Manchester, and somebody went and held up, but it was coming off a removal van, and somebody went and held up a Raspberry Pi Zero, which was in exactly the same position as the Leo coming off, and people saying I could see there's a world market for $5 computers. It was kind of fun. So yeah, it's weird.
I think the other thing I'd add though is that the brand, the Raspberry Pi, the iconic image of the green credit card sized PCB, stands for something now. And so a lot of our work is in schools all over the world. And it stands for democratizing access to computing and computing education, that price shouldn't be a barrier to you owning a computer. And that, you should be able to play with, make, break, create things with technology, and that everybody should have those opportunities. And I think that's one of the things that I think we can look back on now, 10 years on since the launch, is that not only do we have an amazing product, 46 million in the wild, but it also stands for something now, and that's what I think the community around Raspberry Pi kind of shares, is that belief that everybody should have the opportunity to hack about with computers.
But that word break is a really important one. You mentioned your pile of Raspberry Pis you've broken. One of the big things we think we've done with Raspberry Pi is to make a computer so cheap that you can break it. Yeah. The fear of breaking technology, the fear of breaking it, it's back to the bicycle versus car analogy that we used to use a lot early on, which is you wouldn't let a young person in your household probably take the family car apart because it's a complicated thing and easy to break, and once it's broken your family's lost something that's very important. You might let the young person in your family take their bike apart because it's a simpler thing, less likely to go wrong, and if they do destroy it utterly, then they just have to walk. So that idea, particularly with the Zero line, but even the big Pis, of a breakable piece of computer hardware is really valuable.
When my son got his first Sense hat, and we were like, what are we going to do with it? How old he was then? He's 14 now, so we can work back from there. And what he wanted to do was stick it in the freezer and record the change in temperature. And you can do that with a Raspberry Pi, right? We stopped short of the next idea, was let's stick it in the oven and see the temperature rise. And I was like, no, that doesn't make any sense at all. But you wouldn't let him put an iPad in the freezer, right?
All of the components have been in an oven at least once, right? Twice, actually. There's once for each side on the way. Yeah. It's put it in the fridge and see whether the light is still on when the fridge door is
right.
If anyone's interested, by the way, for the people who are here, that computer being delivered, the photograph of it is actually just outside on the wall. So do check it out as you walk past.
And actually it was an Elliott 405.
Yes. There we are. Okay. Thank you for going easy on me there.
One of the things I wasn't expecting, and I was one of those that was right there on the day, frantically refreshing the website, trying to get into order my first one. I'm sure some people in this room were too.
The day when nobody could order resistors.
That's the one. One of the things I wasn't expecting at that point was the community that built up around it, especially sort of people like myself with a few grey hairs who used to love playing around with the user port on a BBC Micro, suddenly having the option to do that again. Were you expecting that level of community to explode the way it did?
Well, the community was really surprising. It's a shame Liz isn't here today. Liz, my wife and our Director of Communications, is about 10 miles away with her parents and our children. Before Raspberry Pi was a hardware company, we were a community of people who were looking forward to getting our hands on a piece of hardware. We announced this in May of 2011 with Rory's crazy blog post, and there was a best part of a year window between that and availability of hardware when really we were a community of people looking forward to that. We were a community of people looking forward to this thing, and that's something we've tried to take forward. And that's the thing that Liz built, and it's the thing that we've tried to take forward into everything that the trading company does, and of course, it's become a core part of the foundation's mission, the sort of decentralized nature of what
absolutely.
you guys do.
Yeah, and it's, I joined a little bit later, so I was, 2015, so by that stage...
You've
the
been
Raspberry
here
Pi
12
community-
years now.
12 years, exactly, yeah. The Raspberry Pi community was already huge, but it's been core to everything the foundation does, the volunteers who are running events, the code clubs, coder dojos, which are powered by people who give up their time, and then, if you think about educators, there is an amazing community of teachers in the UK, but all over the world, who are transforming the opportunities that young people have to learn about technology. And it's one of the best parts of my job is hanging out with them, really.
Yeah. And it's been one of the painful things about the last couple of years.
Oh, yeah.
Yeah, so one of the things that really dramatised to us how, this sort of event is the lifeblood of the Raspberry Pi project.
Yeah.
And when suddenly something happens that means you can't have these anymore,
Yeah.
you feel the loss more than you would have imagined.
I mean, and the really good news, the promising news, is they're coming back, right? So we're starting to see jams, dojos, code clubs coming back now. We held Coder Dojos at the foundation office in Cambridge and oversubscribed for the session a couple of weeks ago. Got some youth volunteers, and what's lovely is some of the kids who were in the dojo a few years ago are coming back now as mentors. So the demand's still there, but yeah, what a horrible 2 years it's been. We've really missed it.
When I was a kid, I used to, every other Friday, and I used to hate the Fridays that weren't those Fridays, 7:30 till 9:30, I used to go to a computer club in my hometown in Ilkley. And a family friend of ours, Alan Drew, used to pick me up. I used to take my BBC Micro, pack it up in its styrofoam box, get my black and white 14-inch television, get them downstairs in the kitchen. Alan would turn up, load them into his car, take it, set it up. And so for 2 hours every week, I had people, like-minded people to talk to about computers, and I had people who I could see what they'd done, and I could show them what I'd done. And audience, this is where Coolest Projects is such an important part of what we do, because it gives people an audience. It's all very well making cool things, but making cool things and then having somebody look at them, you don't have to say it's amazing, just look at them, is really, really, really valuable motivator. And so, one of the things that events like this and events like the ones the Foundation recreate, we talk about recreating, there are reasons why the 1980s is not a perfect thing to try to rebuild, particularly the gender balance in the participation in computing in the 1980s wasn't ideal, but there are some really important aspects of that era that are worth recreating. And I find, the clubs, particularly Dojo, which is the more kind of anarchic, decentralized of the two networks, is very recognizable to me from my childhood and sort of replicates a thing which was really important in my getting involved in computing and staying connected to computing over the years from, I guess, probably from 13 to 18.
Yeah.
So let's move on to the education side of things. Philip, we've just been talking about Coder Dojo, and there are many different projects that Raspberry Pi Foundation are involved in. Can you tell us a bit about them?
Yeah, so we basically do three types of things, right? So we help schools introduce computing, computer science, and related subjects. So that's curricula, teacher training, platforms which are used by students and teachers, and we do that all over the world. We run the National Centre for Computing Education with some partners here in the UK, which is training teachers in every school. And I think at last count, something like 250,000 teachers have taken one of our online courses now. And all of that we're able to do at no cost to schools or teachers, which is amazing. So that's a big chunk of our work. And changing what happens in schools long term is the most critical thing we can do, but it's not the only thing. Kids learn lots outside of schools, as we know. And so the second chunk of work is all about learning outside of schools, and that's online, it's in clubs, it's in youth and community organisations, it's activities that aren't part of the curriculum, like our space program. So that's all about inspiring, giving opportunities.
Can we say like our space program again?
Yeah, no. There's not many charity chief execs who stress about the weather at launch sites for rockets, but I did have a moment there. And it's important to say our work is global, right? So, in India, we're working with Pratham Education Foundation, who work in rural villages all over India with kids who will never meet a qualified teacher in their lives, right? And we are partnering with them using Raspberry Pi devices, but also giving them access to computing education. So those kids are in code clubs, where they're building animations and games with technology, right? It's just amazing. So it's schools, things that happen outside of schools, and then research. So a big part of what the foundation's trying to do is some rigorous research around how do you help young people learn these skills, and how do you try to address things like the gender imbalance. And so we last year launched the Raspberry Pi Computing Education Research Centre at the University of Cambridge, which is a nice kind of circular thing. It's a partnership with the Computer Lab. And so that's kind of what the foundation does, and we do it, as I say, all over the world now.
And how would you say the Raspberry Pi computer itself facilitates that?
Oh, well, lots of ways. So, I mean, as I said, the brand stands for something, which is incredible. The profits from the sale of Raspberry Pi computers is kind of helpful. So
we've returned the occasional.
Yeah, well, it's over 30-something million pounds now, and we combine that with funding from donations, philanthropists, and from governments. But then the products themselves are essential, I think, in two ways. So one is, as we've talked about, Raspberry Pis being used in physical computing projects, and that's not just the main board. I mean, the Pico is obviously huge now. Things like the collaboration we have with Lego. We're helping kids bring their ideas to life through low-cost computing and electronics projects. But then increasingly, the latest generation of devices that Eben and the team create are just giving access to a general-purpose PC. The Pi 400 is just transformational in solving the problem of access to computer, whether you're learning to code or whether you're just, taking part in your homework or whatever else. So those are the different ways, I think. It's core to what we do.
Just to pick up on a couple of aspects of that. One, the money from Raspberry Pi, from the trading business, and the way that interacts with philanthropic, corporate and individual philanthropic giving has been interesting for me.
Right.
That it's the certainty of a stream, the certainty that the organisation will be around in a year's time, or in 2 years' time, or in 3 years' time, makes it a much more fundable proposition for philanthropists. Because, particularly corporate philanthropy, you're very worried that you're going to give money to an organisation that's going to dry up and blow away. And one of the most common mitigations for that is that you make short-term awards, so you make one-year awards. Yeah. That's a nightmare for the recipient because you can't plan long-term. Yeah. It's very difficult for the donor as well, because the donor ends up expending huge amounts of effort on repeatedly administering grants. If you have an organisation that has the stability that comes with a long-term funding stream from the trading activity, you can go out and pitch the idea that, look, we'll be around in 3 years' time. We'll be around in 3 years' time. You know that a lot of our central cost structure is covered by trading money, and so you can make longer-term commitments to us safely. You can be confident that the majority of the money you give will go to the project that you're interested in, to project work rather than to funding central overhead. So that turns out to be a very powerful proposition. We are, I think, the best place for, if somebody wants to make an impact in our area, we are the very best place to allocate money for that, and that's gone very well. The other one is this point about formal engagement with formal education, and how maybe the mission of the foundation has changed over time from having this very anarchic, certainly my view of this is this very anarchic homebrew, home education, home coding world that I grew up in. We've come to appreciate the limits of that and the importance of formal education as an adjunct to that, ensuring that everybody, and we remember in the 1980s, none of there where you talk about making the computing curriculum better, there was no computing curriculum, there was no computing teaching in school effectively in the 1980s. It was then replaced with the nothing was replaced with a very office application-centric curriculum, which has now been reformed. But the absence of formal education means that there will be very large numbers of people, unless they're lucky enough to fall into the hobbyist community world, they'll have nothing. And so providing a baseline of quality formal education to everybody is really important, particularly for equality of access. Equality of access across socioeconomic groups, equality of access across gender, equality of access across any of these axes. You know, formal education is the thing that underpins that, and it's why it's, I think, such an important part of the work that you guys do.
Fantastic. One of the items in our new exhibits is a robot by a young lady called Avi. Yeah, she's part of Coder Dojo and Coolest projects. So can you talk a bit about the importance of young people doing these projects and showcasing their work?
Yeah, Avi's brilliant. I mean, there's so many. One of the best bits of the job actually is getting to meet these young people who just do incredible things with technology. And so there's a couple of reasons why the showcasing storytelling element of it's important. So one is, and this is to Eben's point about computing clubs and so on, getting the positive reinforcement and feedback is super important for them, but they also pull each other along. So what you see with kids who attend Coolest Projects events or Coder Dojos year after year is not only are they very proud and learnt a lot by the thing they've made, they're also looking at what other kids are making and thinking, well, I can do that. And next year I'm going to come back with something more like that. So that's an important part of it. But then also there's this point about role models. You know, and we need, particularly in terms of things like getting more girls involved or kids from different backgrounds involved, we need to be showcasing and shining a spotlight on kids from all sorts of backgrounds so that everyone feels they can be part of this. You know, one of the challenges, I think the legacies from the situation you were describing, Eben, in the 80s and 90s, is that it looks to a lot of young people like you've got to be a certain gender or from a certain background to be in computing, and it's just not true, right?
It's ridiculous. I mean, the computer industry looks like, it looks like me. And that's not right. It's fine that people like me are involved in computing, that's wonderful, but we leave so much talent on the table. You know, from the point of view of the industry, it's a disaster for the industry because, you know, we are starving for talent. I mean, anyone in here who's involved in trying to recruit engineers knows how we are starving for talent. You know, the time it takes to fill any role. So the industry is starving for talent, but also individuals are missing out on the opportunity to have this amazing job. Yeah, engineering just has this PR problem that it's just, you know, they pay you money to sit indoors, good money, to sit indoors in the warm, and every day they bring you problems to solve, challenges, Lego, basically just toys, problems to play, Lego to play with and problems to solve. And they do that every day and they pay you good money to do it. You know, who wouldn't want that job? And, you know, if we somehow create an environment that makes some people feel that it's not for them, that's a disaster for everyone.
Exactly.
Yeah, I'll give you my card later.
In the 70s and early 80s, the government had this TOPS programme, which is to churn out reasonably qualified software developers. And I think that's certainly something that's missing, because we can't rely on bringing offshore people on board year after year, decade after
we've become as a country a little bit a parasite on other countries. You know, we draw people from, you know, particularly my industry, semiconductors, we draw people particularly from India and China. We're just a parasite on these other countries that are doing a better job of educating their engineers. And it's why the changes that we've seen in the last 5 to 10 years are so powerful. But, you know, more government involvement, particularly in adult education, actually. Adult education. Tilly Blythe is one of our trustees at the foundation and is a curator at, what is her role now? She's become staggeringly senior now at the Science Museum. She wrote a study a few years ago of the computer literacy project that gave rise to the BBC Micro. The really interesting thing there was I had having experienced the BBC Micro as a child, my view of the BBC Computer Literacy Project had been very much about its impact on children. But when you go and look at it, how much of that was focused on reskilling adults and providing adults in sunset industries with an alternative route into good employment was very important. And that's probably, if there's a thing that's missing, a lot of progress has been made in the last 10 years, but if there's a thing that's missing, it's probably that focus on adults and probably also the focus on industrial strategy that gave us, if you go to Bristol today, you'll find a place that's chock full of semiconductor engineers. Why is it chock full of semiconductor engineers? Because of INMOS, because of the failed UK government investment in trying to build a national semiconductor industry where the core mission, build INMOS, failed, but spalled off this enormous supply of very, very talented, very, very qualified IC engineers that's now the anchor of this kind of big silicon community. So those are probably, if there are things which are, I guess, out of scope for the foundation, which is very focused on children, if there are things that could be done that are out of scope, it's probably that constellation of industrial strategy and adult education. Digression.
Sorry.
Things we can't solve. Things we can't solve, but
Not
we
yet.
can at least complain about. Yeah. But 10 years ago, we couldn't solve anything, and we just complained about things.
So we're here today to the opening of the exhibition, which you've kindly sponsored, showcasing 10 years of Raspberry Pi. We're open till 5 o'clock, so there's plenty of time for all of you here to have a look at the exhibit and all the wonderful things we have at the National Museum of Computing. For the benefit of those on the live stream, we prepared a short video to give you a little guided tour and sneak preview of the exhibit. Let's take a look.
Is it going to appear?
Hey everybody, Mr. C from the Raspberry Pi Foundation here. We've been working on a brand new exhibit at the National Museum of Computing, and I wanted to give you all a sneak peek on what we've been up to, so come along and have a look. This is the new exhibit here in Milton Keynes at Bletchley Park. You can see here on the wall we've got a Raspberry Pi mounted to the wall, and you can see the map with our micro SD HDMI ports showing you how to put a Raspberry Pi together. And you can see just underneath we've got some Raspberry Pi workstations where you can come in, turn on a Raspberry Pi, sit down, have a play with one, see what it's all about, do some coding, have a bit of fun on the Raspberry Pi. Around here we've got our cartoon and animatic, which explains how Eben Upton invented the Raspberry Pi, came up with the idea to help computer science students around the world. All done in this really cool cartoony style for us, really entertaining. Across here we've got a cabinet here filled with old artifacts, old Raspberry Pis. This one here is one of our alpha machines made in 2011, one of the very first Raspberry Pi designs. Up to the Zero, our tiny little one we were giving away for free. The Pico, even smaller again, and the Pi 400, our flagship unit now, the one that we release for education purposes on young hobbyists all over the world. Speaking of young hobbyists, you can see here we've got all these photos of our community. These are all young people who have come in and been at events that we've run, come and built their knowledge, skills and confidence to use computers all over the globe. And then moving across, we have this interactives table. We have here a Raspberry Shake, which is like a seismometer which detects earthquakes. We have a Piper computer here, which is a really cool self-contained laser cut machine for learners and educators to use. And in our final cabinet here, we've got all these really cool, amazing artifacts, some of the really amazing stuff that Raspberry Pi can do. We've got Avier's Voiceatronic robot here, which responds to voice commands. We've got a really cool little hacked together cardboard buggy at the back there. This is our IZ, so this is a Pi-based video synthesizer, really cool thing. Wildlife camera, a Sense hat, our new build hat for Lego, and then across here in the corner, the coolest thing in my opinion is the Astro Pi unit that went to space as part of our Astro Pi challenge. So come down to Milton Keynes everybody, come to the National Museum of Computing, have a look at the Raspberry Pi exhibit that we've just put together. It'd be really awesome to see you down here. Catch you later.
Fantastic. So let's talk about the future then. I'm hoping that in 10 years' time, we'll all gather here again for 20 years of the Raspberry Pi.
Well, the weird thing is that one of the very, very first events that we did as Raspberry Pi was the 30th anniversary of the BBC Micro at ARM in the spring of 2012. There was an event at ARM, and so it's kind of 10 years. It's kind of not, we've been around. Raspberry Pi has now been around for a quarter of the time that the BBC Micro has been around for, and that's going to keep. 20 years is going to feel fairly momentous, I think.
So what's the aspirations for the next 10 years for the foundation and for Raspberry Pi Limited?
What are you going to do? What are you going to do?
So, I mean, we've got big aspirations. So we think that, you know, every school should offer an amazing computing curriculum for every child, and that's everywhere on the planet, right? And we think, and we partner with organisations now in I think
Pac-Man thing.
50 countries. So we're partnering with organisations in 50 countries to help make that happen. And we also think that every community should have, think of it like music or sport, right? Every school should offer a music or sport curriculum, but every community should have a vibrant sort of network of sports and music activities that young people can do outside of school as well. So that's the kind of the vision. More near term, the big thing that we're doing in the foundation now is expanding into sub-Saharan Africa. So we're just launching partnerships in Kenya and South Africa. We've done a lot of work over the past few years in India. And that's amazing for us, very humbling experience. We're learning a huge amount about those markets. But, you know, for us, yes, we want to have an impact in the UK and America and Canada and Australia, but we're also pushing ourselves to have an impact in low middle income countries. So that's probably the big stretch for us in the next period.
And I guess for us, general purpose computing, right? We want to keep general purpose computing alive. We really believe in general purpose computing as it's not a thing that we don't have a God-given right for general purpose computers to exist. It's almost a historical accident that there are general purpose computers, and obviously the PC and the Mac, the kind of two big surviving members of the surviving representatives of what was the way that all computers were at one point. You know, Raspberry Pi is already, I think, a very important part of the general purpose computing world. We want to make it a more important part. We've always seen ourselves as a PC company, and what you've seen happen over the since we launched Raspberry Pi 4 in 2019, you've seen us really deliver a PC-like experience for the median computer user. You know, it's always been a usable PC for a subset of users, and the size of that subset has grown. I think now Raspberry Pi 4, and we discovered this in the pandemic when we were deploying Raspberry Pi 4s and Pi 400s to young people in the UK who were struggling to access computing, access the internet. We discovered that legitimately 4 and 400 are PCs for the median user. And that will expand, you know, obviously there will at some point in the future be a Raspberry Pi 5, there'll be a Raspberry Pi 6, a Raspberry Pi 10. It'd be interesting to see where we are in, Raspberry Pi 4's proved to be a platform with incredible legs. We've recently posted a performance update from 1.5 to 1.8 gigs, so it's a platform that we are stretching and will continue to try to stretch. I wouldn't like to try and predict how many new Raspberry Pi generations we will have fitted in another 10 years' time. Hopefully a couple, maybe. We might be on Raspberry Pi 6 by then. But really the hope is that, just as the Foundation's mission is that everybody in the world will have an opportunity to experience a world-class computing education. Our mission is to ensure that everybody in the world has an opportunity to own their own general-purpose computer. We think it's transformational. In education, we also think it's transformational in entrepreneurship. You see the number of people who are building their businesses around Raspberry Pi, building their products on top of Raspberry Pi. There's a lot more to do there. Pico and RP2040 open up a really interesting new angle there. You know, that this is now Raspberry Silicon. You know, this is first party silicon. It's a device, RP2040, that's come along at a very interesting time when you can't buy anything else. So it's both, it's a great product, but one of the lessons I think of technology is that a great product is not always enough. People are inherently conservative and will stick with inferior products if they're the product they know. The really interesting thing about RP2040 is it's come along, it's an amazing product, and it's come along at a time when you can't buy anything else. And therefore there is a real push for people to discover RP2040 as a platform, build their products around it. We have people now buying RP2040 from us at 100,000 unit scale who are telling us that their alternative would have been to fold their business up. It would have just to stop, not to shrink, but just to stop because they can't buy anything else. Once they've experienced it, they become very, very excited and enthusiastic and passionate, and they start to advocate for it. We actually have enough material on hand or in process to build now 25 million more. We've sold several million RP2040s. We have material on hand to build by August. Our wafer output and and WIP will be sufficient to build a further 25 million RP2040s. So we really are We really believe in that. You know, it's a wonderful opportunity to both to build interesting new educational products. The Lego product, the Build Hat, is built around RP 2040. We will have future educational products that are built around RP 2040. So it's an interesting opportunity to build our own product, but it's also, as with all Raspberry Pi products, an opportunity to enable other people to do interesting business that they wouldn't have been able to do otherwise. And that's exciting. You know, semiconductor company in 10 years' time, you know.
Yeah, so for anyone who doesn't know, what you do is when you wake up in the morning, get your phone out, open up Twitter and see if he's tweeted morning.
Yes.
At that point, I'd start refreshing pepperoni.
I don't tweet
And
anymore.
yes, that's it. We went through a bit of a... The interesting thing was we went into the pandemic with quite a queue of products ready to go. And so there was quite a lot of, often for a little while, pictures of Kit, my then less than 1-year-old son, on the playmat in the morning. And a picture of Kit on the playmat at 6:45 in the morning was generally, as you said, a sign that you should start refreshing pepperoni. Yeah, we're not done yet.
Excellent. Well, on that point, Helen, do we have time for questions? How are we doing? 1 or 2 questions. Has anyone got a question? Yes.
When you designed the first Raspberry Pi, you didn't have an you didn't incorporate an ADC into it.
Ah, yes.
Now that means that there's plenty of other peripheral manufacturers that benefited from that.
Yes.
Was that a conscious decision?
I don't think it was a conscious decision, was it? We just didn't have any money. Yeah.
They used to call me the hatchet man because every idea they'd come up with, I go, no, it costs too much. We left lots of things off, but the principle that we used was if it needed to be there for the educational mission, we would put it on there.
Mm-hmm.
If you could live without it and perhaps have an add-on board to provide it, like the real-time clock is a famous one, the power-on switch is an even more, and a reset.
By the 20th anniversary of Raspberry Pi, there will be a Raspberry Pi that has a power switch.
You heard it here.
Right, so new product announcement. Raspberry Pi 4 Plus. It's just the Raspberry Pi 4, but with the power switch.
But what is curious, the original manufacturing bomb that was going out to China was not going to have the GPIO header on it.
Yeah.
And by some...
I clearly wasn't paying attention.
No, you clearly the drugs had worked and you left it on.
Yeah.
But that was...
I'm going to tell my bomb story now. Now he said bomb. I'm going to tell my bomb story. So I remember being on the phone to Pete from the departure lounge at Heathrow on my way to California for something in the autumn of 2011 when we were working on really trying to get the thing down to an achievable manufacturing point. And I had a call with Pete and I said something like, could you send me the bomb? Because I'm going to be on the plane for 10 hours. I can do a lot of work on the bomb. I want to go through the bomb a few times. I could do a lot of work on the bomb on the plane for 10 hours. And I was kind of aware of this circle of silence expanding out around me, and knowing where the nearest of the gentleman with the bulletproof vest and the MP5 submachine gun was, and thinking, I hope that circle of silence doesn't intersect with the position of one of the angry gentleman.
Could have been a different story.
But I survived. So that's good.
Fantastic. Well, I'm afraid we're out of time. But that's good news because it means we get to open the exhibition and for you to all have a look at it. So just like to say thank you again to Eben and to Philip for joining us today.
Well, thank you.
We're really privileged to have you here. And here's to 10 more years of Raspberry Pi.
Yes.
Thank you very much, everyone. Thank you.